Hello, this is chapter 10, video number 1. We are starting our final chapter on hypothesis testing, and specifically, how can we make sure that things that we are reporting are statistically significant and it's not just luck. So I'm going to go ahead and go through 3 different examples and introduce you to the language of hypothesis testing and what does that mean in a statistical standpoint. All right, enough vocab. Let's take a look here. A new survey of Americans found that 348 out of 600 adults surveyed are very worried about the economy right now. Earlier polls indicated that only 55% of Americans were concerned. Is this enough information to indicate that there has been an increase in the proportion of adults that are worried? So let's go ahead and take a look at this problem. I have a graph that shows in general how worried people have been, how worried have Americans been about the economy. And if you notice, since about April 5th, for the most part, we are right at about 55%. Sometimes we're a little above, sometimes we're a little bit below, but it seems like we're always right about 55%. Say that they are incredibly worried about the economy. So we're expecting about 55%. Now, we have done a survey, and if you actually divide this out, we have 348 out of 600, 348 out of 600, and you were to simplify that proportion is 58%. So let's take a look here. What we were anticipating is typically we're right at 55%, but the one sample that we did out of 600 people says, you know what, we actually got our sample as 58%. Is this enough evidence to actually say that there has been an increase? Now, journalists are probably going to jump all over that and say, oh yeah, 58%, report it, done. But statisticians actually take the time to figure out, is it possible that maybe we just didn't sample enough people? Is it possible that this wasn't a random sample? Maybe we just chose people that are all going through an economic hardship. Maybe there really is no statistical difference between 55% and 58%. And before reporting this number that there has been an increase, it's important to go through these steps of actually checking to see if this is valid. So we are going to go ahead and introduce what it means to do a statistical test. So graphically, here's what we're looking at. Graphically, we're saying, hey, 55% is what we are expecting, correct? 55% is what we are expecting. However, we got one sample. We have one sample that is all the way up at 58%. And in the next video, I'm actually going to teach you guys how to calculate whether or not this is statistically significant. But we're going to say, hey, is this rare enough? Is this high enough to say that there has been a statistical change? So few vocab terms to remember. All right, first off, let's talk about the parameter. The parameter is a calculation based off of an entire population. So the parameter that we are looking for is we are looking at the overall proportion of Americans that are very worried about the economy. However, it is impossible to sit there and try to calculate the proportion of Americans that are very worried. You would have to go door to door or via email or mail. It is not possible to survey the entire American population, even though we try for some reason for the census every 10 years. So what we did instead is we figured out a statistic. We have one test statistic, and that is our sample proportion of Americans that are very worried about the economy. All right, so parameter, it is impossible for us to actually get a parameter, so this is why we are relying on our statistic of our sample. So here we go. This is what we are learning. This is our new piece of information today. If you've kind of blanked out of the rest, this is where you want to pay attention. All right, first off, a null hypothesis. A null hypothesis. Here's how we are going to write a null hypothesis. A null hypothesis is essentially saying, hey, maybe they just got lucky. Maybe we just didn't sample the right people. So here is our null hypothesis. Our null hypothesis is going to be H sub 0. I know it looks kind of strange, but this is our hypothesis that we're going with originally is that our proportion is equal to 55%. Our null hypothesis is going to be, hey, we're sticking with 55%. I don't think that that's enough evidence to say that we have increased the percent of people who are concerned. However, we are also going to bring up a null or an alternate hypothesis. All right, and let's talk about our alternate hypothesis. How do we write that? All right, well, an alternate hypothesis is going to be H sub A. Sometimes people capitalize the A, other people don't. H sub 0, H sub A. H sub A, this is our alternate hypothesis. Our alternate is going to be, hey, this proportion has increased. It is now above 55%. So this would be a right-tailed test. Our null is we are at 50%, 55%, and our alternate is going to be that, hey, this is enough information to say that, you know what, a lot more people are worried about the economy. And this would end up being a right-tailed test because we're looking how much greater is this. So right-tailed. Right-tailed. All right, so we are going to look at a few other situations. We're going to write the null and the alternate hypotheses together, and then we're going to determine whether this is right-tailed, left-tailed, and we're also going to talk about a two-tailed test. All right, so here we go. I'll scroll on up. All right, over the past decade, a school has a mean SAT score of 560. The scores for the junior class have a mean of 556. Is this enough evidence to say that there has been a decrease in SAT scores? All right, so I'm going to go ahead and draw this out. What we are expecting, what everyone has done in the past, is 560 has been our traditional mean score. However, we have one sample that is at 556. So we've got one sample that is lower at 556. And we want to know, is this enough evidence to say, hey, we have actually seen a decrease in SAT scores? All right, so let's write this out. First off, our null hypothesis, H sub 0, is going to be, now this is a mean. This is a mean. So don't forget that your symbol for mean looks like this. That stands for mean. The other one was a proportion, so we used P. This one we're talking about mean, so we're going to go ahead and use that. So our null hypothesis is going to be that our mean is still equal to 560. Your null hypothesis will always have an equal sign. Null is always, there's been no change. All right, now alternate hypothesis is going to be that our mean is now lower than 560. So your null hypothesis is that, hey, it's the same. That's not enough information to say that we've gone down. But our alternate is going to be, yeah, that junior class is not that great. They are actually statistically lower than typical. All right, so null, alternate. All right, one more example. All right, a body of water has maintained a mean temperature of 24 degrees Celsius. A marine biologist is monitoring weekly mean temperatures to see if there has been a significant change in water temperature. Ooh, all right, I like this one. All right, so here's what we got. We have 24 degrees Celsius is what we are expecting. However, with this wonderful climate change we're experiencing, the marine biologist does not anticipate whether it is going to be higher or lower. So this one is actually going to end up being a two-tailed test. It could be higher, it could be lower. We're just looking for anything that's not equal to 24 degrees. So we're going to go ahead and write these slightly different. All right, so null hypothesis is always going to be equal. So null hypothesis is that our mean is equal to 24 degrees. Our mean is equal to 24 degrees. Now our alternate, well, we don't know if it's going to be higher or lower. We just want to see if it's different. So the symbol for, hey, not equal to 24 degrees is this, not equal to 24 degrees. And this would end up being a two-tailed test. We would have to test lower and higher on this one. And that's what we will do in the next video. Oops, I guess I forgot to say this one, since this is lower, this one would be a left-tailed test. All right, so in conclusion, Null hypothesis, you're either talking about proportions or means. Null hypothesis will always have an equal sign. Alternate hypothesis, you could have a right-tailed test that is greater, a left-tailed test that is less, and then a two-tailed test that is just not equal. We don't have a gut instinct as to whether we're going one way or the other. And that is how to write hypotheses. Now we're going to talk about how we can actually test to see which one of these hypotheses we should go with.